So in this lesson, what we're going to look at is something called the Polygon sum conjecture. And what we're going to come up with in this lesson is a way to figure out the amount of degrees of the interior angles of any polygon that we're given. So before we get started, why don't you take a second to go over the launch activity and define the triangle sum conjecture, and then unpause the video and we will go over it. So remember, the triangle sum conjecture states that the sum of all three angles in a triangle add to 180 degrees. Okay. So again, if you take the three angle measurements from any given triangle and then add them together, you're going to get 180 degrees. All right. So what we're going to do is we're going to use this to kind of help us determine the sum of the angles in any polygon. So what we're going to do is we're going to take a look at convex quadrilaterals, pentagons, and other polygons. Remember, convex means something that is, all of the diagonals are inside of the shape. Okay, so this would be a convex quadrilateral or a convex polygon because all the diagonals are within the shape. But if you looked at a concave polygon, remember a concave polygon would be where you have something like this, where you'd have at least one diagonal that is outside of the object or outside of the polygon. So again, convex, all of your diagonals are inside of your polygon. So the question that we want to look at, is there a polygon sum formula? So like we have for a triangle sum conjecture, is there one of these statements that we can make for the angles of any polygon? So what we're going to do first is I want you to draw a quadrilateral. Remember, a quadrilateral is four-sided shape. It can be any four-sided shape that you want, and it has to be a convex quadrilateral. So go ahead and draw your quadrilateral. I'm going to go 1, 2, 3, and then 4. And what we're going to do is we're going to pick one vertex in the quadrilateral, and we are going to draw in all the diagonals from that vertex. And remember, a diagonal of a polygon is defined as any segment that connects two non-adjacent vertices. And that means, in other words, it's a line segment that connects two vertices but isn't a side of the polygon. So if you take your quadrilateral, I'm going to choose this vertex right here. The only diagonal that I can draw is from, and I'm going to label it A, B, C, D, is from A to C. Okay? I can't draw from A to B a diagonal because, remember, it says a diagonal is not a side of a polygon. And I can't draw from A to D. So first ask yourself, how many diagonals could you draw here? The only number of diagonals that I can draw with a quadrilateral is one diagonal. Now I want you to look at your diagonal, and I want you to see how many triangles do you see. So if we look at this, we see one triangle, we see two triangles. And if you draw in any quadrilateral you want, here's another diagonal, you notice again 1, 2 triangles. So regardless of which quadrilateral you draw, what your quadrilateral looks like what you're going to have is there are going to be 2 triangles in all quadrilaterals. Okay, so you draw on your diagonal, you're always going to only have one diagonal, it's always going to create 2 triangles. Now think about what we know about our triangle sum conjecture. We know that the sum of any triangle is 180 degrees. So the question is, how many degrees must be in your quadrilateral? Well, if we have 2 triangles, and each triangle has 180 degrees inside of it, 2 times 180 is 360 degrees. And again, regardless of what quadrilateral you drew, you're going to have two triangles in it. And those two triangles, the sum of their angles is going to be 360 degrees. And since your quadrilateral is made up of those two triangles, we can then take that information and we can create a conjecture called the quadrilateral sum conjecture. And what the quadrilateral sum conjecture states is the sum of the measure of the four interior angles of any quadrilateral is 360 degrees. So if you have a quadrilateral, you now know that the sum of all four angles of that quadrilateral is 360 degrees. Now what we're going to do is we're going to take a look at some more some different polygons. So we have and what we're going to do, our goal is to come up with an equation that would allow us to find the number of degrees in any polygon. So I have a table here. First thing, we're going to fill out what we just completed. We have a four-sided polygon, which we know is a quadrilateral. And again, we're going to have the number of sides represented by the letter N, and then the letter D is going to represent the number of diagonals, T is going to represent the number of triangles, and then the final column is the total number of interior degrees, which is just 180 times T. So we said a quadrilateral has one diagonal. It created two triangles. It gave us 360 degrees. So let's take a look at a polygon or a pentagon. So a pentagon is a five-sided shape. You're going to choose any vertex you want. I'm going to go right here. I'm going to draw in my diagonals. Again, remember diagonals are lines that go from one vertex to non-adjacent vertices. So here are my only diagonals I can draw. So with this pentagon, regardless of what pentagon you drew, you would see that you could create two diagonals. And if you look at this, you have 1, 2, 3 triangles. So we have 3 triangles that were created. And we know that each of those triangles in the triangle sum conjecture has 180 degrees. So we know that the total number of degrees in this shape, it would be 3 times 180, which is 540. Okay, so we have 540 degrees. Now, we're going to continue doing this. So you go ahead and draw your hexagon, and then your heptagon, and then your octagon. So we have a 6-sided shape. Again, these get to be a little bit tedious to draw. So 1, 2, 3, 4, 5, 6. Again, make sure it is a concave or convex polygon. So I'm going to choose one vertex. I'm going to go here, 1, 2, 3. So if you look at that, I have 3 diagonals that were created. We have 1, 2, 3, and 4 triangles. If we use our triangle sum conjecture, we have 4 times 180 equals 720 degrees. So we see that a hexagon has 720 degrees in its interior angles. So if you look at this, you probably can kind of see a pattern. We don't necessarily need to draw the 7-sided shape or the 8-sided shape. You could if you want, but you look at this, the number of diagonals seems to be increasing by 1 each time. And the number of triangles seems to be increasing by 1 each time. So if we wanted to find the number of degrees in these shapes, we would have 180 times the number of triangles. So 180 times 5, which is 900. And then 180 times 6, which would be 1080. Okay. Now, if you look at this, we have what we call the pentagon sum conjecture. And the sum of the measures of the 5 interior angles of any pentagon is 540 degrees. And we could continue going on and on and on and on to figure out, we could have a hexagon sum conjecture. We could have an octagon sum conjecture, and so forth and so forth and so forth. But our goal, again, is to come up with a way to figure out the number of measure of the interior angles of any shape. Okay, so again, you can fill out this table. We would have 6, 7, 8, 9, and we'd have 7, 8, 9, 10, and then 7 times 180 would be 1260. Again, this is just increasing by 180 each time, so then we would have 1440. We would have 1620. And finally, that 12-sided shape, which we don't want to have to draw, would be 1800. Okay? So we have found the number of diagonals that are created in each of these shapes. We have found the number of triangles that are created in each of these shapes. But our goal is, what if we wanted to figure out the number of degrees in a hectagon, which is a 100-sided polygon? What about an n-gon, a polygon that has n sides? And in this case right now, what we would have to do is we would have to continue this table all the way up to 100, and also figure out, what would that, that would be a lot of writing, unnecessary writing. So what we would like to do is find an equation for the n-gon, because if we can find the equation for the number of degrees in any polygon, regardless of the number of sides, then we could quickly figure out, without having to write down any numbers in the table, what the number of degrees is in a hectagon. So let's think about this. How are we figuring out the number of degrees here? Well, what we're doing is we're multiplying the number of triangles formed, t, by 180. So what that tells me is that we want to be able to quickly figure out how many triangles are created, regardless of how many sides there are in the shape. So do you notice a relationship between the number of sides and number of triangles created? 4 and 2, 5 and 3, 6 and 4, 7 and 5, 8 and 6. If you keep looking at this, 9, 7, 10, 8, 11, 9, 12, 10. That relationship that you should notice is that for an n-gon, the number of triangles created, which is represented by the letter T, is equal to the number of sides minus 2. Okay, so if we wanted to create this, what we would have, if we wanted to write an equation for this, would be the number of degrees is equal to the number of the sides, which is represented by the letter n. So n minus 2, and then so that gives us the number of triangles, and then we took the number of triangles and we multiplied it by 180. So what we come up with is the Polygon sum conjecture. And what that states is that the sum of the measure of the interior angles of an n-gon, so an n-gon means any number, 15, 16, 17, 18, 19, it's an equation for any number of side polygon, would be equal to 180 times n minus 2. Okay? So you take that and you're able to then quickly find the number of degrees in any polygon. So if we were to take a look at this hectagon, this 100-sided shape, how could we do that with this equation? Well, we would have 180 times 100 minus 2, which would be 180 times 98. And if you use your calculator, you would get 180 times 98 would be 17,640 degrees. Okay, so there would be 17,640 degrees in this 100-sided shape. Okay, so I know I don't have this example here, so I'm gonna draw in this example real quick. Let's say we have a polygon that looks something like this. Again, bear with me while I draw this in. So we have that information where that's 90. This angle right here is 120 degrees. This angle right here is congruent to that angle. This is angle A. Let me don't put that marking. So there's A. This is B. And this is 72 degrees. So if we wanted to figure out what A and B were, we'd have A is equal to, B is equal to. So we could quickly figure out what B is equal to, because B is a linear pair with this angle with a measure of 72 degrees. So linear pair is 180 degrees. You subtract the 72 we already have, we get 108 degrees. Now, we would need to figure out what angle A is. So we would like to know the total number of degrees inside of this polygon, which happens to be a 1, 2, 3, 4, 5-sided polygon, which is a pentagon. So to find the total number of degrees inside that polygon, that pentagon, we know that the equation we can use is 180. Let me rewrite that. 180 times the number of sides, which is 5, minus 2. 180 times 3 is going to be 540. So we know that there are 540 degrees total inside that polygon. And we know what B is. And we know that this angle over here is 90 degrees. And we know these two angles up here are 120 degrees. So if we take 540 minus 90 minus 108 minus 120 minus 120. And hold on, I typed that in correctly. We get 102. So we find out that A is 102 degrees. So that would be how you can apply the polygon sum conjecture to find the missing angles of a polygon. So if you have any questions while you're working on your homework, please message me on Remind or email me, and I will answer your questions.